So, all right, greetings, wonderful people. So what we got for today, solve equations using the property of equality and using inverse operations. So those are the two things that we're going to be working on today. So when we solve equations, what exactly does that mean? So just like in the previous lesson that we had, there is a difference between equations and expressions. So an expression does not have an equal sign, and equations will have equal signs. So something like this would be an equation, all right? And something like this would be an expression. Let me just make it a little bit more. Yeah, there we go. So this is an expression, that is an equation. Now, there's another kind of misconception out there, and that is anytime I show students, a problem and they say, well, what should we do with it? They always say, let's solve this problem, right? Now, solve, it means something specific. Solve doesn't just mean work on it, okay? I think that's what a lot of students think. They think that the word solve just means work on it. Now, when you solve a problem, there's usually a particular type of problem. Like, for instance, let's say your car is not starting. Is changing your tires going to solve it? No, it's not going to, tires don't have anything to do with the electric portions of your vehicle. So in that case, it would not be a solution. It would help. All cars would look better and perform better with better tires, but in this case, we have a particular problem of the vehicle not starting, so we do need to have something else done to it. So that's not a solution. So solve in this case means to get the variable by itself. That is what you do. So there are other types of directions. So in Algebra 2, there are going to be different things like graph, factor, simplify, evaluate, and all sorts of other directions. So solve is a very specific direction. So don't just go around saying everything needs to be solved, because not everything needs to be solved. It only needs to be solved if there is a variable and you are trying to find out what that variable is. And in that case, let me go ahead and put another thing in there, and that is solution. So a solution is what you can put in to make it work. So again, just like my vehicle example, there are certain parts that you would need to replace to have different effects on your vehicle. So that's what the solution is. So what your basic steps to follow, and I have a much better poster in my classroom. It's got a lot more steps on it, but unfortunately, this is what we're gonna have to work with for now. So on your packet, it tells you the steps to follow would be step 1, distribute. So anytime you have parentheses, you've got to get rid of those parentheses because they mean different things, right? So the number you're looking at inside the parentheses is not always going to be the number you're looking at or the number that you need to work with. So you've got to make sure you get rid of that distribution. And then before you start moving numbers from one side to the other, you've got to make sure that you simplify. You've got to simplify some of these things on both sides. So this is another thing that I see a lot of students doing, is that if they see two things on the same side, for whatever reason, they want to subtract both sides or something like that. So you've got to check each side of the equal sign and make sure that they don't have any like terms that you could be combining. Now, after you've taken care of each side, you have to choose one side for the variable to go on. So that would be step 3. So move the variable to one side. And it's important to take care of your variable first. Now, when we're working on here, we're not going to be working on the variable first each and every time, just to save some space, because on some of these, we're going to have to do a little bit of work to get to the solution. And last step is to solve using your inverse operation. So working in a way, kind of working backwards. But inverse, again, inverse means backwards, which means kind of opposite, but I don't like using the word opposite because, opposite's it works, but opposite is kind of like a word you learn in, 3rd grade or kindergarten or something. So it does kind of make people gravitate toward that, but it's not really the opposite, because like multiplication and division are not the same. Okay, like again, they're not different, I should say. They are the same thing. It's just one's going forward and the other's going backwards. So let's go ahead and work on this. Now, you could do something like this. So let's say, what number can I plus to 5 and then times it by 6 to get 12? Oh, that's a tough one. And in fact, sometimes it might not even be a whole number, which is why we need to work with inverses, because you can't just keep plugging things in and seeing if it works, because sometimes you might have something that is a fraction, which it looks like we're probably going to get in this case, because I can't think of any numbers that you add to 5 and then times by 6 and you will get 2. All right, so first things first, let's go ahead and again get rid of this parenthesis. So I'm going to go ahead and multiply both sides and make sure I multiply both of these things here. Now, I got to be careful. I'm a little bit tired today, so I might make a few mistakes, and that's just because, well, I got that vaccine yesterday, and it's painful. I don't know. Like I've been getting vaccines for the flu pretty much every year of my life, I should say, ever since I don't know, as long as, you know, for the past few years, I've been getting that vaccine. But man, this one hurt. So, and it's very rare that shots hurt, but this one's, I don't know, it's just something different about it. All right, so we took care of the distribution, and it kind of kept me up last night. So we took care of the distribution. Now we already have n on one side. N is already here. So we can go ahead and skip step number 2 and 3 because the variable is already on one side. So we can go right over to step 4, and this is to start moving numbers around. Now, anytime you run into something like this, you always ask yourself, what are these numbers doing to the n, or whatever variable you're looking at? So here we have add 30. So we do the inverse of adding 30, which is minusing 30 from both sides. Now here we have 6 times n. So we do the inverse of timesing by 6, which in this case will be dividing both sides by 6. So 6 divided by 6 is 1. That's why we have identity property. 6 divided by 6 is 1, and we don't, when we're writing n, we don't write 1n, we just write n, because 1 times anything is going to be that same number. So n is equal to, and it looks like we're going to have a fraction. So anytime you end up with a fraction, remember, you always ask yourself, can you divide it, or can we reduce it? And in either way, it's always, you know, both of those are simplifying. So when you say simplify a fraction, that means you either divide it or you reduce it. So in this case here, it doesn't look like we can divide it, so we're going to have to reduce it. And we can go with the other method that I showed that we had before, and that is to divide both sides by 2, which it looks like that's going to be what we have to do. It looks like we're going to have to divide both sides by 2. And it looks like we ended up getting the what we needed, and we're done. So negative 14 thirds. And again, that's not something you would have guessed trying to plug things in and seeing if it worked out. It's just not what most people would consider when they're trying to plug things in to see what works. Now, in this next problem here, this is another one that I get people stuck on quite a bit, because they see fractions and they go like, oh no, a fraction, what do I do? They freak out. So don't be scared of fractions, okay? Just remember, fractions are more scared of you than you are of them. So let me back up. So remember, you got to ask yourself, what are these numbers doing to the variable? So in this case, we have x. Now, x is being times by 3. It's being subtracted from 5. It is being times by 3. And it is being divided by negative 4. So there's a lot of stuff going on with this. But pay attention to that last one. We are dividing it by negative 4. Now, we want to get rid of fractions. Why? Because we got a group. There is a group. Don't forget that fraction signs are a group symbol. That's what we learned in the previous lesson. So groups are one of the first things we have to take care of when we are working with solving. So we got to undo this fraction. We got to, how do we get rid of a fraction? Okay, so a fraction's weakness is the bottom number. Without the bottom number, it's not a fraction anymore. So again, remember, x is being divided by -4. So we do the opposite of divide by -4, which is times by -4. And anytime, and you know, if you've been working with solving equations for a while, you know, you probably learned it when you were in 7th grade or so, at least, you know, depending on how far along you were and all that stuff. But hopefully you have a bit of experience, so I don't have to explain too many things. But again, you just undo it and that will get rid of the number. And you've been doing it that way. So again, if you see like a plus, you do a minus. If you see a minus, you do a plus. If you see a divide, you do a multiply, and so on. Now in this case here, I'm going to multiply -15 and -4, so we get +60. And I'm going to double check, make sure that we got all of these things in the right place, which it looks so far so good. And that's how we got rid of the fraction. So now there is no more fraction. See, I told you fractions aren't that bad. And again, we got to learn how to use fractions because they're not going anywhere. Okay, fractions are just a fact of life that we're going to have to deal with. Now again, x is already on this side here, which is good because that's the side we want it to be on. We want the variable to be on the left side. That's just the normal way of working with these kind of problems. And I don't know why I wrote this one out when it would probably be easier to type it out. But 60 minus 15, and that will get rid of this here. So minusing 15 on both sides. And again, we're trying to get that x by itself. So we got to get rid of these. So we got rid of the 15 now. Let's get rid of this -9. So to get rid of a negative number, you got to get that negative out of there too, right? So you don't just divide by 9. We also have to divide by the negative because negative divided by negative is positive. And in this case here, it looks like we will get a whole number, not a fraction. So 45 does divide by 9 easily, and we get Oh, okay. I think no wait. Oh, like I said, I'm a little bit off today. I'm looking at this and it was positive 60, but somehow minusing 15 made it negative. So no, that's not right. So it looks like we got it right here. So go ahead and box that one in. So it should have been negative, and I knew it was negative, but whew. Anyway, there we go. So I just spaced out on that one. All right, it looks like we're done with this page. Let's move on to the next one. All right, so this one doesn't look so bad. It looks like a regular type of problem. So let's go ahead and start by distributing that 2. So 2 times 2 and 2 times -4. Sorry. 2 times -7 is -14y. Minus 5 equals 111. And I'm going to put this underneath here so that way it's kind of this. So when it's lined up, I can kind of see if anything's going on. So if I made a sign switch, I can easily spot where the problem would be. Now here I also have, if you look at step 2, it says to simplify each side. So I have 4 and -5, and I get a lot of students that will do something like say add 5 to both sides like this, plus 5 here. No, you don't do that to the same side. If they are on the same side, you just combine them. It's just like 4 minus 5. So that would be -1. Okay, so I just put the -5 and the 4 together. So now I only have one thing to do. Now I have to get all of these numbers away from the y. So I'm going to add 1 to both sides. So +1 here, +1 there. And I get -14y equals 112. Now, does 112 divide by 14? Yes, it does. And we get a nice 8. Oops. Let me go ahead and divide both sides by negative 14 here. So divide by negative 14, divide by negative 14. And again, y equals negative 8 because a positive divided by a negative will be negative. And box that up and call it the answer, and we're done with this. Now again, the solution is what you need to put in there to make it work. So if I were to plug in negative 8 here for y, it should work out. And in fact, let's go ahead and test it. And this is how you check any problem for its solution. So negative 8 and negative 7, put them together, you get 56, positive 56, because negative times negative is positive. 2 times 56, or sorry, 2 times 2 plus 56 would be 58. Times that by 2, so I'm evaluating it essentially, we get 116. Minus 5, we get 111. So to check it, we would end up with something like 111 equals 111, which is true. So that does balance the equation. It does make it work. So therefore, it is a solution. Okay, now let's go ahead and work on this one. And it looks like we get fractions. Woo! So fractions are one of those things. You just gotta, again, we just gotta keep moving. Now, when multiplying fractions, I think I mentioned this in one of the previous lessons, we just multiply top number to top number and bottom number to bottom number. Now, you can do this a little bit of an easier way, which we call cross canceling. So cross canceling means you look at numbers on top and bottom and then divide both of them. So like in this case, I have 15 and 5. They're both divisible by 5. So divide that by 5, divide this by 5, divide this by, well, 16 and 4, again, cross meaning top and bottom. And you get 3 over 4. Now, if you don't want to do it that way, you know, like if you're not comfortable doing it that way, then you can go ahead and just work on the problem regularly, right? So 15 times 4 is 60. And 16 times 5 is 80. Now, looking at this, you can reduce it. All right, so you can reduce it using normal fractions. It's the same way you reduce a normal fraction, I should say. So be careful with some of these. So 15 times 32 is 480. And 16 times 3 is going to be 48. So it looks like we got 2 big fractions. Now, again, you could still use cross cancel on this. That way you don't have to reduce it. Now, I'll show you cross cancel in another problem. So 60 and 80, what is the largest number that can be divided by both of those? And you might be thinking 10, because they both end in 0, which is true. They both end in 0, so they're both divisible by 10. But then you would end up with 6 over 8. And in that case, they would both be even. So 6 over 8, those two numbers can be divided by 2. Or we could think of the greatest common number that both of them divide by, which is 20. So 60 divided by 20 is 3, and 80 divided by 20 is 4. There we go. Now the fraction has been reduced to lowest terms. And this one is another one where you might be looking at it and thinking, that looks kind of easy. 480 does divide nicely by 48. And in this case, we get 10. Now, I don't like fractions either. So there is an easier way we could get rid of them. Ugh. And I'm going to show you a trick on how to get rid of fractions. But actually, in this case here, actually, it might be easier. It might be better for me to show you the other way to do this one here. But what I'm going to do is I'm going to go ahead and continue pushing numbers away. So here we get negative 26. Wait. Negative 26. All right, something's not working out here because I don't think it's supposed to be 26. Oh, I see what it is. And I did this in my other class too. Now that negative has a tendency to blend in. Looking at it, it's really close to the fraction, so it's really easy to miss it, which actually means this is negative and this is negative. So in this case here, well, if you notice a mistake like this on your own stuff, you know, don't. I think a lot of students have a tendency to want to just redo the whole problem over again. But it's sort of like if your headlight on your car goes out, do you buy a whole new car? No, you just fix the part that needs to be worked on. So just look at all of the things that it would have affected. So again, in this case here, that negative would have been distributed to both of these. So that just means I just changed both of these to negative. Sorry about that. -6 equals -3/4 times q. Now think about it. What number can I times by -3, then divide it by 4 will give me 6? And that's a weird way to think about it. But actually, if you think about it that way, it does make a lot more sense. Times it by -3, then divide it by 4 to get -6. Now, if what I'm going to do here is I'm going to multiply both sides by 4 because I want to get rid of this bottom fraction. So here I get -24 equals -3q. Now, by removing one of the steps, I have a different number to go for. Well, I know that if I divide -24 by 4, I get -6. So instead, I'm going to ask what number can I times by -3 to get -24. And now what I'm also going to do is I'm going to switch sides. So both sides are going to switch sides. So q is on the right side. But anytime we're working with equations, we always want to put the variable, the thing we're solving for, on the left side, or as I sometimes call it, the first side. All right, so like, let me just think of a name, like John. All right, John's like the most common name I can think of. Like if I said John is 8 years old, that makes sense. That's the way we normally talk. We don't say 8 is John, because that sounds weird. That's not the normal way people describe things. So in English, we always talk about the subject or the object and then the adjective. You know, like if I said John is 5'2", we don't say 5'2" is John. So we always put this, so we say Q is 8 instead of 8 is Q, which is what it would have looked like if we had gone with this part here. So there we go. We are done with this one. And again, these fraction ones are a bit of a hassle, but you know, it is what it is. We just gotta keep going with them. All right, let's go ahead and do this next one here. So on this one here, I have a, right? We have a variable on both sides. So what do we do if there is a variable on both sides? Well, we got to pick one side for the variable to go on. So we don't have any distribution. We don't need to simplify both sides because there are no like terms. So on this side, I have no regular numbers, or I only have one regular number and one variable. Same is true with this side, one regular number and one variable term. So we can't really do that. So we have to go move over to step number 3, and that is to move the variable to one side. And like I said, it's usually best to move it to the left. So that's what I'm going to do. And in this case, it works out great because my variable stays positive and it's now on the left side. Now, on the poster in my room, and usually with my Algebra 1 students, I will almost always do one step at a time. All right, and this is what I mean. I'm going to do something like this. So I get 16a and minus 7. So in this case here, I only did one thing, and that is add 6a to both sides. And that will cancel this here. And normally what I would do is I'd also add 7 to both sides. So this add 7, like in this step here, for some of the problems in this lesson, I am going to do that. I am going to do 2 things at once. Now in this case, it's not a big deal because I have enough space to write everything I need to. But sometimes I won't. Sometimes, like with the fraction ones, there's going to be a lot of work that I need to show. So I might end up having to kind of combine steps. Anyway, so here we go. We got 16a equals 28. So that means what number can I times by 16 to get 28? Well, in this case, nothing comes to mind. So we're just going to have to use the inverse property and reduce it. So 16 divided by 16, that's going to leave us with just a. But now I have 28 over 16, which again doesn't divide nicely. So we're going to have to reduce it. So they're both even. So let's go ahead and do that. So 28 divided by 2 is going to be 14. So that's going to be 14 over 8. And in this case here, if we thought about it, we could divide both sides by 4, right? So 28 divided by 4 would be 6. Oh, wait, no. 24 divided by 8. Wait, what am I talking about? 28 divided by 4. That would be 7. And 16 divided by 4 would be 4. So in this case, we end up with the fraction of a equals 4/7. And we can't reduce it anymore, so it has been reduced to, or simplified to lowest terms. Now again, in some of these other problems, I am going to combine some of these steps, but this is the way I recommend it. This is the way, like I said, if I'm teaching this to usually, younger students, or less experienced students, I'll usually just teach them, just go one step at a time. But in this case here, sometimes out of necessity, I'm going to need to do 2 steps at a time. Anyway, back to here. So let's look at this here. And I'm going to show you an easier way to work with fractions, because this is a really good opportunity. And I almost did this on the last one with fractions. And I know some students might say, oh, I don't like the way there's so many different ways to do this. All right. But honestly, you kind of have to understand multiple different ways, because if you learn only one way, that's not really going to help you all that much. You need to know kind of why you're doing this type of math stuff and how it works. And if you use it multiple ways, it will oftentimes, kind of be like, okay, now I know why it works that way. I know how it works. Whereas, that's another misconception about math, is people think math is about following steps. No, not necessarily. You don't always have to follow steps. You can really do your own thing sometimes, and you can just, once you understand it, you can just sort of work your problems in whatever order you want, although there's still an easiest way to do this. Okay, so now what I did with this first one here is I only took care of the parentheses. That's the only thing I did. Everything else is still the same, but I got to be careful. I got to watch out, because that negative can be tricky. It'll hide. And in this case, it has been hiding. So by hiding, we got to make sure that we make this negative, and this negative times this negative is going to turn it positive. Now we have all of these bottom numbers. All right. So I'm going to show you an easy way to do this now. Kind of a thing to watch out for with this trick here, this technique, is you have to be careful, because it only works when you have an equal sign. Now the first step of this is to look at your bottom numbers. Looking at my bottom numbers, I got 5. Well, 1 is under 21, so we're going to ignore that. So 6 and 3 are the only 2 numbers that we have. I want a number that can be divided by 6 and can be divided by 3. Now we could pick something like 12, and it will work out. But let's keep our numbers small. In this case, 6 is probably the best option, because 6 can be divided by 6, and it can also be divided by 3. So I'm going to multiply everything by 6. Now, more specifically, it's 6 over 1. Now, if you want the over 1 part, because it's easier to work with, go ahead and do that. But if you're working with a whole number times a fraction, then you only multiply the top number. So 6 times 5 is going to be 30. Now, the bottom number is not going to change, so it's going to stay 6. And 6 times 21, so 6 times 2 is 12. 6 times 1 is 6. 6 times 2 is 12. Don't forget the negative. Sometimes when I'm writing these, I don't say the negative. All right. But that is what's going on. Now in this case here, 6 times 9 is 54 over 3. And now you're looking at this thinking, well, what was all that for? Why did we do all that? Okay, so we have different fractions now. The top numbers on all the fractions are bigger. Let's now check to see if, like anytime you have a fraction, we check to see if we can divide it, and then if we can't divide it, we simplify it. But in this case here, because we picked the bottom number to multiply everything by, it should work out. So 30 divided by 6 is 5W. So 30 divided by 6 is 5. Put the W on. And then we still have 126 equals, then here we have negative 12 divided by 3, which would be negative 4. Ooh, and I almost forgot the W on that one. Even though I was paying attention to the signs, I almost forgot the W, because if you look at the very, very top, there is a W there. Now 54 divided by 3, and that is going to be 18. And there we go, no more fractions. Fractions are gone. Okay, so fractions are gone now. We don't have to worry about them anymore. From here, we can work on the problem like we would just about any other type of equation. Now, I did say that the next step would be to pick a side for the variable to go on. But in this case here, you notice that I'm near the bottom and I'm running out of space. So what I'm going to do is, instead of working with just this one here, I'm also going to do another thing. All right, so I got rid of this 4 so I could move it over on this side. But I'm also going to do one other thing. I'm going to take 126 and I'm going to move that away from the W. Since I've chosen this side to be my W, 126 has got to go. So now I did 2 things. This is canceled out also. So both sides have lost something, but both sides have gained what they wanted. This side wanted the W, and this side, let me go ahead and get negative 108. And I'm going to go ahead and divide that by 9, and that should give me 12. So W equals negative 12. And all I did here was just divide both sides by 9. All right, so again, I'm going to try not to skip any steps. But now we got this problem done, and we got it in the space that we needed to get it done at. So yeah, I know fractions can be a hassle, but again, we can't get rid of them. You go to Home Depot, just about everything in that whole store is going to be written in fractions. You know, you're going to have to do some kind of fraction to get it, or it's going to be marked or measured by fractions. Okay, go ahead and do this one here. So I don't see any trick with this one, so let's go ahead and get started on it. So negative 5 and 8 would be negative 40. Minus, and 6 times 5 would be 30. Now again, don't forget to multiply both of those by the negative, right? So we got to have both of those be negative. And it looks like nothing's going on this side, so I'm going to go ahead and just leave everything the same. But I will need to get rid of some of these things here. I don't see anything on the same side. So I think we can go ahead and start solving this. So I'm going to go ahead and plus 5p to both sides. And like I said, normally I would just do one step and then move to the next step. But just to save some time, save some writing, sometimes I also put a slash here. That way you can tell that there is, that's where the equal sign is. Now, because I canceled the P on this side, I'm going to cancel the regular number on this side. So I'm going to add 30 to both sides. And here I have 40, or actually I should say negative 40 plus 5, so that would be negative 35p. And the 30 is gone, it cancels out. I should have crossed it out. And on the other side of the equal sign, I have 5 plus 30, which is 35. Now again, if I have a negative, I have to divide both sides by the negative, because it's not enough to get rid of the 35. I also have to get rid of the negative, right? We got to get it all the way by itself, as by itself as we can possibly get it, which is usually all the way. And in this case here, it looks like 35 divided by 35 is pretty easy. It'd be 1. And again, don't forget the negative, because you divided one of them by the negative. And we're done with that one. All right, now I got next one here. So I don't really see anything. Oh, there is a bit of a trick on this one here. Don't forget that if you see a negative, think of it as, you can think of it as a negative 1, but really you're subtracting that whole group. So that 7m is being subtracted. So 7m is being subtracted. And the 3 is also being subtracted. That whole group, everything in that group is being subtracted. And again, you can think of it as negative 1 times both of these things. That is, if it's easier for you to think about it like that, then, you know, whatever helps you think better. And in this case here, it looks like, looks pretty okay. Now we move on to the second step. We took care of our parentheses or our grouping symbols. The next thing we got to do is to simplify both sides. Now look for like terms on the same side of the equal sign. In this case here, I have 2 constant terms. And remember, the constant means it does not have a variable. So 16 and negative 3, if I were to combine those, I get 13. 6 minus 3 is 13. And it looks like everything else has stayed the same. So that takes care of that. Now I can start moving things to one side. So I'm going to pick a side for the m to go on. And again, at some point, it's always got to be on the left. Okay, always on the left at some point. So I'm going to move it to the left. And in fact, this works out pretty well, because if I move it to the left, it stays positive. And moving it to the left is, when you're working with equations, that's great. But when you start working with inequalities that are the less than and greater than symbols that look like the little mouth, those ones you got to be a little bit careful about how you do these here. So it's best to learn both of them. All right, learn both of them. All right, so since something canceled on this side, I'm going to have to cancel something on this side here. So I'm going to have to minus 13. And usually when it gets kind of messy like this, you know, you might want to put a little bar between there, and you don't have to, you know, if you're pretty good at keeping track of your numbers, maybe you may not need to do that, but that is something that helps plenty of students. And this is also going to cancel the 13, so they both lose something here. Now we have only m on this side, so that is 7 subtracted from 8, so that would be 1m. So m equals, and what do we have on this side? 8 minus 13. 8 minus 13 would be negative 5, and it looks like we are done with this one. And that one wasn't a very tricky one, but I think the thing they were going to try to get you on was this part here, where you have to make both of these negative. And I did mention that in a previous lesson, that in that previous lesson, you should have, again, I should have mentioned that you would have to distribute a negative by itself because you are subtracting this whole group. All right, let's see how much further I got. Not that many. We're on our last few slides. And I think there's about 20 examples altogether. So let's go ahead and keep things moving along. And we run into some more dreaded fractions. Oh, man. Okay. But again, let's not be afraid of fractions. Let's get used to them so that, you know, in anywhere you go, there's always going to be fractions. You know, you're never going to get away from them. And I always do run into college students and even adults that don't know how to do fractions either. So don't fall into that trap. And I won't let you. I'm going to try my best not to let you fall into that trap of getting your fractions forgotten. So let's go ahead and work with this one here. So again, we're going to do what we did, I think, on example number 2 or something. I don't remember what example that was. I know we did one where I told you to get rid of the fraction first. And I think that, yeah, it was number 2 or so. Might have been 4. But anyway, this is a grouping symbol. In my previous lesson, in the very lesson before this, I said fractions are grouping symbols. So you got to work with the groups first. So this means I'm going to times everything by 2 on this side and also times everything by 2 on this side. Now by timesing it by 2, that cancels out the 2. And again, if you want to get rid of a fraction, take out the bottom number, because without the bottom number, it can't be a fraction anymore. So now it's just going to be a regular number. 2 is gone. So 10x plus 17. And now we run into another one of these things that I was talking about with the last example, and that is a negative group or a minus group. So we got to minus the x and minus the -9, or take away the -9. Or think about it this way, take away a negative. If you take away a negative, it becomes positive. Or negative times negative is positive. You know, those are 2 ways you can think about it. Now on this side here, I do have to multiply both sides by 2, distribute that 2, and I'm going to move this underneath that so that I am not messing with it, right? And if they're lined up nicely, I can easily see, you know, because like sometimes I will forget about the negative sign because they are easy to lose track of. They're really little, and sometimes they blend in with the other numbers, especially fractions. So now we have a couple of different things. So now I have a lot of terms on this side. So I have an x term, right? So there's 2 x's, and now I also have 2 constants that are, again, numbers without variables. So I have to put these together first. So that's step 2. Simplify both sides. All right, so 10 minus 1, because remember the negative x means negative 1x. So that would be 9x. Now with the next one here, we have 17 and 9, and that would be 26. Oops, forgot the plus. And this side has not changed. We have not done anything to it, so it will stay the same. So it will stay 6x plus 2. Okay, there we go. Now we've simplified both sides. Next, we need to pick a side for the variable to go on. So again, always look at the variable first and actually get into the habit of trying to look at the variable and ask yourself, is anything going on with this? Is there anything weird? Which in most of these, there won't be anything weird. There we go. And now we gotta, since we canceled the x on this side, we should cancel the regular number on this side. So minus 26 on both sides. And here we get 3x equals, and the 26 should have canceled out. And it looks like we have negative 24 here. And we just need to divide both sides. So we still got to get rid of this 3. So again, that's 3 times x. So we do the inverse, which is divide by 3. And it looks like we're ready to get our answer out. So x is equal to negative 8. And again, there's a lot of stuff going on with this one, but don't be scared. Okay, don't be scared. Like I said, fractions are more scared of you than you are of them, so be careful. I mean, like fractions are only like that big and you're like way bigger than it. Anyway. And for this one here, every time we come up with these fraction ones, I'm always kind of like, what should we do with it? Because, you know, with these fraction ones, there's oftentimes a lot of stuff you can do with them. And I could stick with the simplest ways, but then the simplest ways also have a lot of things going on with them, so they look complicated, so sometimes people don't want to do them. There are easier ways, but unfortunately the easier ways, you have to learn how to do the easier ways. So it requires you to know the shortcut in order to take the shortcut. So again, simplest way, let's make everything into a fraction. So I turned all my numbers into fractions. So my whole numbers, I just put 1 under them so that they would be fractions. Now we multiply them out. And in this case here, we could use cross cancel, but I'm gonna go ahead and again, I'm gonna keep it simple. So 9 times 4 is 36 over 8. So 8 times 1 is our bottom number. And here we have 9 times 1. And then 8 times 2 is 16. 3 times 1 is 3, and 4 times 1, the bottom number is going to be this. And don't forget the a, or the variables. 3 times 15, sorry, well, 3 times 5 is 15. And 1 times 2 is this here. And again, I have a big, gigantic string of fractions. Some of these can already be reduced. But let's do that trick that we learned earlier. So again, if you have an equal sign, look at all your bottom numbers. So I have 8, 16, 4, and 2. So there's a lot of stuff going on with this. So the biggest number, so we want something that can be divided by 8, can be divided by 16, can be divided by 4, and can be divided by 2. Which in that case, it might be easiest to look at the biggest number, which is 16. So divide everything by 16, I'm sorry, times everything by 16, because 16 can be divided by 16. Now we're gonna get some big numbers, but that's okay. We're gonna use our calculator here. And 36 times 16 is 576 over 8 minus, and then 16, now in this case, if you know cross cancel, it would be a lot easier to do it this way, which in this case would be 144 over 16a equals, and then 16 times 3, 16 times 3 is 16, 32, 48. So we should get 48 here, 48 over 4a plus, and then 15 times 16 is 240. 240 over 2. Now we didn't change any of the bottom numbers, but we can divide these now. So 576 divided by 8 is just 72 minus, and this should be 9a equals 48 divided by 4. I'm pretty sure that's going to be 12a plus, and this is 240 divided by 2, so it's going to be 120. So even though we got some big numbers and we had to do a little bit of work, sure as heck beats working with fractions, because if we had to do this with fractions, it would still be pretty much the same thing. If we were trying to add and subtract fractions, we'd have to change all of the bottom numbers to something like 16, which actually may not be that tough, but you would still get pretty much the same thing. Now let's go ahead and get a by itself. So here we have a bit of a problem because, well, if I minus 12a, a is going to be on the left side, but it's going to be negative. Now you can easily fix that by just switching the side that a is on. Or we could move it over to, you know, we could also add 9 to both sides. So we do have a bit of a conundrum here. Do we switch sides or do we have to divide by a negative? And I think on the last one, I don't remember what we did the last time. I think I said something like John is 16 is what way we should have said it. But I said something like 16 is John, or the age might have been different. But either way is good, okay? You're not going to get it wrong. It's just what do you want to do? So I'm going to go ahead and minus 12a from both sides. And at the same time, since I'm minusing 12, I'm also going to get rid of something on this side. So I'm going to minus 72 on both sides. And that's going to cancel this out. Now, at this point, I have no more fractions, so I should be able to get this pretty easily. So I'm going to get negative 21. And equals, oh, almost forgot the A. 120 minus 72 is going to be 48. And now we need to divide both sides by 21. So divide by 21, and it looks like we're going to end up with a fraction because 48 cannot be divided by 21. So we're going to have to think, what is the largest number we can divide by both of these? So 48 and 21, 48 cannot be divided by 7. So we could try 3. We could divide both of them by 3. So 48 divided by 3 is going to be 16. Over, and then divide this by 3, we get 7. And don't forget the minus, the negative. Now, because that negative does have a way to blend in, what I normally do, this is what I do, and I kind of suggest you do the same thing, is put the negative on the top number. So it's a little bit more visible. It means the same thing. And when I'm checking papers, it's a lot easier for me to say, oh, okay, that's a negative number. Because I know some students will put the negative like right there and it'll like blend in. It'll almost look like the same line. So don't make that mistake. Easiest thing to do is put it on top, especially if you've been in Algebra 1, you work a lot with like linear formulas like y equals mx plus b. And m, or the slope, is usually a fraction which you use for rise over run. And it's a lot easier to see that negative. If your slope goes down, then you know it's going to be a negative. So anyway, that's it for this one. Let's go ahead and keep things moving along. Now, I did say when you're working with these kind of equations, look at the variable first. Okay, that's your priority. Okay, you're trying to get that variable out of there. You're trying to rescue it, basically. So the reason why I have you do that is because there are special cases, and special meaning that it doesn't really happen a lot. So these are kind of rare. So what's going on? Now be careful, because there are 2 types of special cases. Now let's just do this one here and just use our regular way of doing things. So distribute the 5. So 5 times 1 is 5, and negative c. So 5 times negative c is going to be negative 5c. Now work with your like terms on the same side, which in this case I have 2 c's. So 5c and 8c. Well, actually, it's going to be negative 5c. So that's going to be 3c. Oops. 3c. Now with this here, what would be the next step we would do? Now, if I ask students, usually in a normal class, I'd ask students, what would you do here? Well, let's go ahead and minus 3c from both sides, because that's what you do, right? You want to get rid of the variable from one side so that hopefully it will be more meaningful on the other side. Now here we run into a problem, and I usually get something from students, something like this. And this is a bit of a weird one, because this happens a lot. And I ask students, what did you do? And they'll say, I minus 3c from both sides, and it canceled on this side, but became 1 on this side. And I'm like, you sure? You sure how that works? I mean, if you do the same thing on both sides, it should be the same thing. Now, in this case, we end up with a statement. We don't have a variable anymore. The c is gone because they had the same c, and now the c is gone from both sides. So what do we do with this? Now, the actual answer for this is no solution. That is the actual answer you would get. Now, why is this no solution? Well, it's false. When we lost the variable, it is a false statement. 1 is not equal to 5. Since it's false, this tells us that it's going to be a no solution. Now, no solution means no matter what you put in there, it's not going to work. All right, so like some cars might have a big problem. Like, for instance, let's say you drive a really old car, like a 1960s type car, and the transmission gives out, like the transmission case just breaks. In that case, there's not really a solution unless you can find another one. So in that case, your car is probably never going to run again. Now, if your car is kind of like mine, where the transmission does have a tendency to break, it's hard to find new ones for it every year. So mine might give out any day now. All right, now we still have a second case. Now this second case is different than the first case, but let's see how it works out. Now nothing happened to this side, but now I'm gonna have to distribute over here, and negative times negative is positive. Now, at this point, you might notice something's a bit weird, a little bit off about this problem. And remember how I said that you should work with variables first? This is one of the reasons why, because looking at this, you might notice, again, something is weird. And never ignore when something is weird. In this case, I have negative 8x on both sides. Now, if I were to get rid of that negative 8x by adding 8x to both sides, we run into the same kind of problem. The x is gone now. Now, I'm not bothering with the number. I easily could do something like minus 40 from both sides, and I would get something like 0 equals 0. But just to kind of show you, I'm going to leave it at 40 equals 40. Now, what's going on here? Now, again, this is different. So even though these two things look the same, it would be a different answer, a different solution. Now, in this case here, the solution is all real numbers. Okay, the solution is all real numbers. Anything you put in there is going to work. Remember, if I plug in, if I have x here and I plug in, say, 1, I'm going to get a statement like, in this case, 40 equals 40. If I put in something like x equals 100, I don't know what it is, but I might get something like 140 equals 140. That's true. It's always going to be true. So that's why this is different. Now, again, the way you tell is because if you have the equation here, it will be a true statement. So again, these two things look the same, but they are different cases. So again, false means that it's not going to work out. Nothing will work out. All right, I could plug in any number in for C in this one here. And if I plug in any number I can think of, including whole numbers, negative numbers, fractions, decimals, integers, irrational numbers, nothing is going to work. It's just never going to work. Okay? I'm always going to get a false statement like 1 equals 5 or 76 equals 81 or something like that. I'm always going to get something that's not true. So again, those are the two special cases, and be careful because, well, I kind of wish these were more common. I think in the work that I'm picking, I try to get ones that do have these. So it is worth learning the difference between a no solution and an all real numbers. All right, now it looks like we only have about 6 more problems to go. And we started a bit late. So we started like almost 10 minutes late. So we're gonna have to just keep going until this is done. So I wanna remind you that Second hour starts at 9:20. Now with proportions, these are a special kind of equation where you have two fractions. There's fractions on both sides and they're all entirely fractions. And we're gonna do something, it's sometimes confused. I know students confuse this all the time with cross cancel, but it's cross multiply, or sometimes they'll call the other, right? They'll switch the names. But cross multiply is you are multiplying across the equal sign. So in this case here, I have my top number 5 times my bottom number of this here. So that's going to be 5. And remember, a fraction is a group. So there is a hidden parenthesis there that you got to worry about. So I multiplied that 5 and I just put them in parentheses. Now in this case, it was pretty easy on this side. I don't know why I put a there. I think I meant just a typo. But here from now, we got rid of the fractions. And this is very similar to what we did when we were multiplying the entire fraction to get rid of, the entire thing to get rid of the fractions. It's sort of the same thing. Now, if I showed you both of them side by side, you'd be like, oh, okay, I can see how they're the same. But I just don't have the time today, so let's go ahead and keep things moving. So I'm going to go ahead and distribute 5 so that we no longer have the parenthesis. And let's see, keep solving the regular way and should be no issue. And there we go. Doesn't look like we can do anything with this. We can't really reduce it. We can't divide it. We could probably turn it into a mixed number, which in this case would be something like 2 point. Well, if we turn it into a decimal, it'd be 2.8. But like I said, I don't like decimals. So unless we really have to work with decimals, I don't really want to work with decimals. And I'd rather show you fractions because, again, that's the area I think most people will be weak at. So let's go ahead and do this one now. So if it helps, again, you can circle it, but sometimes the circles can be a little bit distracting and cover up important information. But I'm going to just go ahead and show you how I got it. So that'd be 10 times 2x minus 8. So again, top number of one fraction to the bottom number of the other fraction. Now, in this case here, I'm going to go ahead and start with the regular way that you would write a fraction, the normal way that you see fractions. I'm sorry, groups, that distributive. So that's 8 times 5x minus 9. So I just switched the order so it makes a little bit more sense. And I'm going to go ahead and now I'm going to distribute. So that's going to be 10 times 2. So that's going to be 20x minus 80 equals 8 times 5. I'm pretty sure that's 40, but I've been kind of spotty today. So there we go. Okay, now, I know I did a problem like this before where I was like, should we just divide by negative? And I think that's what we did on the last one because I knew we got a negative here. All right, so here I moved the a to the right side, so I'm gonna do the other thing, and I am going to minus 20x. And like I said, there's not really a worst way to do this. So whatever you choose. Oopsie, and add 80 to both sides. And like I said, if you need to put a divider here, do what you need to do because it helps younger students, it helps less experienced students, or even if you just need a little bit of help organizing things, it helps out a lot. All right, so now let's cancel out what we have. So cancel out this, and it looks like we're also going to have to cancel out oh, you know what? I canceled out the wrong thing. I should have showed that before. Oops, sorry. Looks like we're going to back up a little bit. Now, since I canceled something on this side, I'm going to have to cancel this instead. So I'm going to have to cancel this by adding 72 to both sides. There we go. And that should cancel this here. So now I have 80 and 72. So 80, what is that, -8? -8 equals 40 minus 20. So 40 minus 20 would be 20x. Now the x is on the other side. It's on the right side. Now, if we had done this the other way, it would have been something like -20x equals 8. And you would still get the same thing. The answer would still be the same, whether you move the x to the right or to the left, wouldn't matter. But let's go ahead and divide this. So we still have to divide by 20. Now again, even though x is on the right side, when we write our answer, we should make it so that x is going to be on the left side or the first side, because that's just again the proper way to say anything in English, really. You know, like you say, I am, and you would describe yourself, or you know, this is, you know, whatever, however you're describing it. You know, the ball is green or something. The pencil is blue, something like that, you know. But you would oftentimes talk about what you're talking about and then describe it. Now, let's go ahead and get back to here. So 20 is canceled. Just like this, 20 has been canceled. 8 divided by 20. Now, we can't divide it, so let's go ahead and reduce it. So think of the largest number that we can divide both of these by. So divide that by 2. Wait, no, I'm sorry, 4. 4 is the largest number that will divide both of these. So 20 divided by 4 would be 5. So there we go. Now we have reduced it to lowest terms, so we don't need to worry about that anymore. All right, so how am I doing on time? Okay, I got a few more minutes, so I think I can squeeze these last ones in. Now these last ones, again, these are one of those ones that I always see people getting stuck on, just like with the fractions or missing negatives, okay? These ones are called literal equations. Now, I don't know why students are really bothered by this at times. They sometimes won't, you know, I'll get like a homework in and some of them will be blank. But don't let these scare you either, because you handle these the exact same way you handle all of the other ones we've been working on. Any normal equation, it's the same rules. You look at what you're working with. So in this case here, we're looking at pi. Now it's going to tell us right here what we want to get. So we want to get this pi by itself. Maybe so we could eat it. Hey. But we got to get rid of this 2 and we got to get rid of that r. Now we can't subtract it, and I think that's one of the things that students will do is they'll try to subtract it, but that's not what's happening to it. What are the 2 and the r doing to the pi? Well, they're multiplying it. So if they're multiplying it, we should do the opposite of multiply, or I should say the inverse of multiply, which is to divide both 2 and r, and that will get rid of it. So 2 divided by 2 cancels, r divided by r cancels. And now I'm going to switch sides. So switch the sides so that pi is on this side, c over 2r. Now this is a little bit different because when we normally solve something, we're able to get a value for it. Like in this case here, well, we got fractions in these cases. But sometimes you will get, you know, whole numbers. You will get numbers that you can easily plug in. And what makes these easy is even though you have a lot of steps, you can plug, like once you start working on it, every time you do something, there's less numbers, less letters. It gets smaller and smaller to work with, like puzzles. All right, like if you buy a box of big puzzle pieces, the first ones are usually the hardest because you have so many puzzle pieces to choose from. But as you start putting the puzzle together, it starts getting easier and easier. Well, I guess the picture also kind of depends, but in general, usually the less things you have, it gets easier. But in this case, it doesn't. We don't lose anything. Nothing is lost during this process. So it's the same rules that you would always use. So moving on to this one here, you want to get P by itself, which means this A and that half has to go. Now, we have 1/2 times, you know, what does it mean when you 1/2 times something? Oops, still got the problem on there. So I want you to think of something. Let's take half of, I want you to take half of, well, pick another number. Let's pick 16. What is 16 times half? Or half of 16. So I'm going to times it by 0.5, which you know is half, and that becomes 8. So timesing something by half is the same as dividing it by 2. So again, it makes a lot more sense to know what, you know, how these things work out. So what I'm going to need to do is multiply both sides by 2. Now I'm still trying to get this 2, but I'm trying to get this P by itself. So 2A equals, and now half of 2 is 1, the multiplicative inverse, if you will, which if you remember, that was one of the first lessons we did. And it just goes like that with anything in math, okay? Anytime you're working with math, you need to know what was in the last lesson, you know, so you can use it in the next lesson. So that's why you got to be here every day. All right, but we still got to get this P by itself, which means I got to divide both sides by A. And I'm going to switch sides, and this is reflexive property. I think I've said that before, but if I haven't, that's reflexive property, and that is, you can reverse the order and it still means the same thing, the order of the equal sign. And in this case, we get 2A over P. Now, this is the actual answer, and but sometimes I will get students that will ask me, wait a minute, if I have an A on top and A on bottom, can't I cancel it out? And that is for the most part true. But in this case, when you're working with these kind of equations, capital and lowercase can mean different things. They mean different elements, different terms. So like for an example, I don't know what this is. It could be the area of a triangle, but why would they use A and B, or sorry, A and P when it should be base times height, or B and H, or something like height and width? You know, something like those make more sense. So this could be the area of a triangle, but it could also be an average. Both of them start with A and would be thus capital A. Capital A stands for average or area. So usually when it's a capital letter, it means something specific. Like in this case, C is for circumference. So that this is the formula for the circumference of a circle. So when you see a capital letter, it's usually different than a lowercase letter. So just be careful with that, because lowercase and uppercase are not going to be like terms. So don't combine them. All right, let's go ahead and do this next one. Now, I don't know what formula this is. I don't think it even is a formula for anything. And if it is, I don't know what it is. But again, we have the bottom C. So this means I need to times it by 6. Wait, why did I say 6? I'm sorry, C. I just realized, where the heck did I get 6 from? Anyway. Now that gets rid of our bottom thing, because if you multiply anything, like if you times it by 3 and then divide it by 3, you're going to end up with the exact same thing. All right, there you go. But now we're still trying to get B by itself. So in this case, now we're adding A. So we got to do the inverse of plus A, and we got to minus A. So now B is by itself now. So B equals 5C minus A. Now in this case, A is not a like term to 5C. Since they are not like terms, we cannot combine them, right? So I might get some students that might say something like minus 4AC or 4AC or something like that. No, they're not like terms. So you still need to follow the order, procedure for like terms. So in this case here, that is what we got. So again, you're just working on them the same way you would work on any other type of equation, but just be careful. I mean, the rules are the same, but sometimes it handles a bit differently. Now in this case, I know what this is. This is a linear graph, and this is standard form linear. So in this case, you'd have a line that passes through the point 8 and -8, or sorry, passes through the y-axis at 8 and then passes the y-axis at -8, something like that. Anyway, now this is pretty common for having to work with linear formulas, the y equals mx plus b. So sometimes you might have to solve it for one of them to see what you would get for either the intercept or the slope or something. Now, let's go ahead and get rid of this 3y. So I'm going to add 3y to both sides. Now again, these are not like terms, so I'm not going to put them underneath each other. I'm going to put it a little bit off to the side. So now I get 3x equals 24, and I'm going to just put it like this. And you know, you could say y plus 24, which is kind of correct. And in fact, actually, I think that would be a much better way to write it, because again, standard form says that you should start with your highest power variable and move to your lowest power variable. But this works out. Okay, I'm not going to be picky about this one. In fact, this I would do this the exact same way I'm doing it now. Now, when you have multiple terms, like in this case, I have 2 terms on the opposite side. When you have multiple terms and you want to get the x by itself, in this case, we got to divide everything by 3. So everything gets divided by 3. And I think that's pretty much it. One other thing I guess you could have done was divide everything by 3 on the first step. And that way you would have had much smaller numbers to work with, but you know, it is what it is. All right, I think we're on the last one, last slide, but I think we're gonna finish just on time. So again, I gotta keep things moving. This video will be posted, so you can watch it again if you miss anything. Or wait till the end and I'll take questions. But some of these lessons are pretty long, so just bear with us. All right, now I'm going to go ahead and distribute the 1/2. So this is 1/2 times W plus 1/2 times V. Now you probably could use a calculator on this one because it has, you know, easily convertible fractions to decimals. But I'm going to use that same trick we used earlier, and I'm going to times everything by 2. So timesing everything by 2. Now we get rid of the 1/2 because 1/2 times 2 is just 1. And now we have much smaller numbers to work with. So that made it really easy because now I don't really need to do anything else. Let's just get this W out of the way of the V. Now V is going to be by itself, but again, I'm going to switch the sides using reflexive property, just switch the sides that they go on, and you get 13W. And there we go. Now we know what V is. We solved this equation for V. And again, remember, solving means to get the variable or whatever you're looking for by itself. Now, I don't know what this is formula-wise, but I know what this is. I know that this is I think it's called the interior angles of a polygon. So N is the number of sides and S is the, think of the angle measure. So like if you wanted to find the interior angles of a triangle, so there are 3 sides, 3 minus 2 is 1, and 1 times 180 is interior angle. So if you imagine a triangle, all 3 angles on the inside equal to 180. And this can be used with anything. Like if I wanted to know the interior angles of a pentagon, 5 minus 2 would be 3, and 3 times 180 would be like 540 degrees or something like that. Anyway, enough about that. Let's get this n by itself. Divide both sides by 180. And I'm going to switch sides again. So this is going to cancel out the 180. Now remember, this is a group times 180. So actually it would stay the same. So this would be n minus 2 equals s over 180. And from here, I would just add 2 to both sides. So plus 2 to both sides. And that should be enough to get me what I need. So I get n equals, and that should be s over 80. But I'm going to try to type it out. So there you go. That is what that would be. Let's box it up because that's our answer, final answer, the solution to what we need. And that is pretty much it for today. And remember to try to get to your classes on time. All right. I mean, I know some of these lessons are a bit longer, but if we started on time, we would have gotten done with this before the bell rang. Now it's only lunch next, so don't worry too much about it. But just for the future, okay, try to get here on time. I'm gonna probably next week start doing something about that. Anyway, that's it for today. I will see you guys next time. So that is it for now. Bye-bye.